Alrighty, here are three problems about solving where the variables on both sides of the equation. If we have variables on both sides of the equation, we're going to want to try to simplify as much as possible. So using the distributive property, combining like terms, anything like that. And then after that, we're going to want to move one of the variables over to the other side. And how we do that is through an opposite operation, just like we do with constants. This is a positive 2x. I'm going to move it to the other side by subtracting 2x from both sides. Because a positive 2x minus 2x, those are going to cancel each other out. They're going to go away. So this becomes 3x plus 6 is equal to positive 27. So again, this is 5 of something, and we're taking away 2 of that something, so we have 3 of that something still left. Make sure you don't cancel out the x's. We are still having 3 of that something. But now this is a two-step equation to solve. Subtract 6 from both sides, so this becomes 3x equals 21. And do the opposite operation of multiplication, and that is to divide. So we end up getting x is equal to 7. Now this one, we're going to combine like terms on both sides. X minus 6x is going to be, remember there's a 1 there, negative 5x plus 4 equals 6 minus 2 is 4, and then we have a minus 5x. So we want to move all the variables over to one side, so I'm going to add 5x to both sides. And if you notice here, negative 5x plus 5x becomes 0x. And I'm not even going to write the 0x. But the x's go away. All that's left here is just 4. Negative 5 of something plus 5 of something, it all goes away. Same thing here on this side. You end up with 4 is equal to 4. And when you get a true statement like this, like 4 equals 4, negative 9 equals negative 9, that means that there are an infinite number of solutions. Infinite number of solutions. And what that means is that no matter what you put in for the variable, whatever you substitute in for the variable, both sides will always equal each other. In this previous example here, the only number that I can put into this equation to make both sides equal to each other is 7. If I try any other number, like 0 for example, 0 becomes 6 equals 27. And that doesn't work. That's not true. But if I put 0 in here, this would be 4 is equal to 6 minus 2, which is 4. So that does work out. No matter what, you're always going to have an infinite number of solutions. Now with this one, I combine like terms. Negative 8x plus 9x, so that gives me a positive 1x, and then the plus 6 left over. Negative 17 plus x. To get rid of the x's, I'm going to subtract 1x from both sides. But again, on both sides, the x's go away. On the left side, I'm just left with 6. On the right side, I'm just left with negative 17. These are not equal to each other. Not equal to. That means that there are no solutions. You'll see in the back of the book, if you're checking your answers, it's going to write it like this. But we can just go ahead and write out no solutions, and that's fine. This is just a symbolic way of writing it. But no solutions. This means that no matter what number you put in for x, you can never make both sides equal to each other. It's impossible. So those are just three quick examples for solving when you have a variable on both sides of the equation.